Hi everyone, we're going to look at our lesson from section 3.4 where we are solving quadratic equations by factoring. Now you will recall that we have already learned how to solve quadratic equations by graphing, but we also saw some shortcomings in that method, seeing that our graphs didn't always touch or fall exactly on an integer, which then makes it hard to identify exactly what our solutions are. So if you look where we have been, this graph here, this parabola that's graphed is showing us the graph of y equals x squared plus 2x minus 3. When they work through the process and get it graphed, we find that the solutions show up at -3 and at +1. Remembering that the solutions are also given the name of the zeros of the functions or the roots of the function. So you might hear it called by different names, but it's called the zeros of the function. It is because that is where the function is equal to 0, where our f of x or where our y is equal to 0. It finds us the x value. So you can see here graphed that we get -3, 0, where the function is 0, or 1, 0, where the function is 0. Now, where we're headed is to understand today how to factor this function into two binomials or pulling out a GCF, and to take those factors and find where the function is equal to 0. So if I would replace a 1 here, 1 minus 1 would make this 0, so one of the products would have to be 0. Or if I replace a -3 here, that would make this second binomial 0, making our two products or our two factors equal to 0. So what we're going to look at is why these factors give us 0, how to work back to standard form, and how to work into factored or intercept form. So when we have two solutions, they go into our two binomials as such. Now you'll remember that the signs back here were opposite. So when I would go to solve this, the solutions to this function would actually be -3 and +2 once I set them equal to 0. But I'll explain that in a little more detail shortly. If I FOIL these, that takes us back to our standard form equation. So firsts give me x squared. Outsides give me -2x. Insides give me +3x. And lasts give me -6. So that when I simplify my outers and inners, I get an equation that looks like this. X squared plus x minus 6. In standard form, that takes this shape. Now, when we were in standard form, we can clearly see our quadratic term, we can see our linear term if it exists, and a constant if it exists. Now, all three of those terms should have a coefficient that is an integer, not a fraction or a decimal. Okay, so now if I look at our generic factored form, I get an equation that looks like this. A times x minus p and x minus q when p and q represent our intercepts or our zeros or our solutions or even our roots of the equation. So p and q are going to represent where we cross the x-axis in the function. So let's look at a problem where we're going to use this factored form to find our quadratic equation. So in this problem, it says the quadratic equation has -3 and 6 as its roots. That means if I solved it, that x was going to equal -2/3 and x is equal to 6. That's where we're going to cross the x-axis. It says write the equation in the form ax squared plus bx plus c. That's just standard form. So what I'm going to do is I'm going to start with factored form. So our factored form starts as the expression x minus p and x minus q, and that's going to equal our y value, which should be 0. Now, it's telling us what our roots are. It's saying, well, our roots are -2/3 and 6. So I'm going to go ahead and replace those up here. So I'm going to write this as x minus a -2/3 and x minus 6. Now you're going to see automatically that that -2/3 is going to change the sign, and that +6 is going to remain -6. And that is the value of our function y, which is 0. Now, this is our factored form because these are our two factors. What I want to do is put it into standard form, so we're going to FOIL that. So when I do my firsts, I have x squared, my outsides, my insides, and my lasts. 2/3 times -6 is -4. Now remember, it says that a, b, and c have to be integers. So in order for me to make them be integers, I'm going to multiply all of my terms by the greatest common denominator. So since I only have one denominator, which happens to be 3, I'm going to multiply this entire expression by 3. So that's going to leave me with 3x squared minus 18x plus 2x minus 12. Now I don't want to forget to, 3x squared minus 18x plus 2x minus 12. Yes, sorry, I had a brain freeze for a second. So now I'm going to take my outers and inners, and that's going to give me a -16x, and that should be minus 12 when I look at that function. This would be the quadratic equation in standard form. So you can see that we can look at these problems in different forms in order for us to find what our solutions are. Typically, when they're in standard form, we either graph it or we work backwards to put it into its factored form, and then we'll use what's called the zero product property to find us our roots. So in order for us to do that, it's kind of like coming full circle. Understand where our solutions are and how to get our equation so that when we have our equation, we can understand how to get our solutions. So in order to get our solutions, we need to understand the zero product property. So the zero product property says if you have any two numbers that are multiplied together in such a way that your product is 0, then that must mean that either A is 0, or B is 0, or A and B are both 0. So since that's what I'm looking for and what I'm relying on is that the value of the function is 0, I'm going to look for where my factors are equal to 0. So if you can see in this example that we have it in factored form, to solve this when they're equal to 0, we're going to set each individual factor equal to 0, and then I could solve this. This would give me x equals, when I subtract 5, -5. And this would give me, when I add 7, +7. So my two solutions to this factored form would give me -5 and +7. All right, so let's start with an equation in standard form and work our way to factored form and solve. So first of all, since I'm solving a quadratic equation, I want to have it set equal to 0 because I'm looking for the zeros. So I'm going to bring that 4x over. So I'm going to rewrite this so that it's x squared minus 4x equals 0. And you can see that is standard form because you can clearly see the quadratic term and you can see the linear term. Now you'll recall back to our factoring practice and remembering that in order to find the G factor, we're going to look for our GCF first. So I look at both terms and I see that they both have an x in it. So the first thing I'm going to do is pull out the GCF. That's going to leave me with x minus 4, and that's equal to 0. So I am going to look at both pieces and reevaluate and see, will anything factor again? If not, then I set up as two pieces that are set equal to 0. I'm going to rely on the zero product property. And that zero product property says that I can set both equal to 0 and solve. So when I add 4 to both sides, I get a 0 and a positive 4 as my choices for my solutions or my zeros of the function. Now it says, let's check this by graphing. So if I recall graphing this function, which is x squared minus 4x, I want to find the axis of symmetry first. So my axis of symmetry is going to be located at negative b over 2a, or it's going to be located at positive 2. I'm going to put that in there. Since I'm running out of room, I'm going to make my table of values go horizontal, where I'm looking for 2, and I'm going to go 2 to the left and 2 to the right and see if I have to pick any more. So when I plug in my values, I'm going to plug 0 into my function. 0 squared minus 4 times 0 is 0. When I plug in 1, 1 minus 4 times 1 is negative 3. When I plug in 2, I get 4 minus 8 is negative 4. When I plug in 3, I get 9 minus 12 is negative 3. When I plug in 4, I get 16 minus 4 times 4, which is 0. So actually, by factoring and by graphing, we're able to see the solutions in 3 different ways. We were able to see them using the zero product property. We're able to see them graphically because we're crossing the x-axis at 0 and 4. And we're even able to see it in our table of values because my f of x is equal to 0 when x is equal to 0 and 4. So we're able to see this algebraically, graphically, and with those tables of values. All right, so let's practice solving quadratic equations by graphing. So I'm going to look at this next example. Now, as soon as I see a quadratic term and a linear term, I'm going to make sure that my equation is set equal to 0. So I'm going to bring that 9 over, and I'm going to look at factoring this. So I look for my GCF first, and my GCF is 1, so I have nothing to pull out. My A is 1, so I'm going to go ahead and factor my x's as such. Now I'm looking for factors of 9 that are going to add to be negative 6. So that could be negative 3 and negative 3. So I'm going to place those in for my P's and my Q's. And I'm going to test it. So I'm going to do x times x is x squared. My outsides give me negative 3x. My insides give me negative 3x, which is negative 6x. And my lasts give me 9. I reevaluate and see if anything could be factored again. If not, then I'm ready to solve. Here's my A, here's my B, and they're set equal to 0. So using the zero product property, I'm going to set each factor equal to 0 and solve. Now in this case, since both my factors are the same, that meant that this was my perfect square trinomial, because I got a perfect square when I factored it. And that also means that both of the solutions are going to be exactly the same, that x is equal to 3 and 3 only. That means if I would check this one by graphing, that it's only crossing the x-axis once, which means that the vertex is probably, not probably, but it will be hitting at the value 3. So 3 is our only solution. Remember, when we solve quadratics, we can get 2 solutions, we can get 1 solution, or we can get no real solution. All right, so let's look at our next example. Now I'm going to show this one to you actually two different ways. The first way is the way we've been looking at this for the last several lessons or for the last several days. Notice that in this equation, I am lacking that linear term. I only have a quadratic term and I have a constant. When you have this special case that no linear term exists, I actually do not have to have this one set equal to 0. What I can do automatically is apply the square root property. And the square root property says if I have x squared by itself, I can square root both sides. Now, nice and simple, the square root of 36 is 6, but when I square root x, I have two choices because x could have been positive 6 or it could have been negative 6 to start with. So when I graph this, it would have crossed the x-axis in two places, positive 6 and negative 6. Now, let's reevaluate this one. So say we forgot that we could use the square root property and you just set it equal to 0 first. So we would get an equation that looked like this. Now you'll remember, hopefully, that this is the special factoring case, a DOS. A DOS stands for difference of perfect squares. The difference of perfect squares is going to factor in such a way that my signs are one of each, and then I take the square root of 36, which is positive 6 and negative 6. Once I evaluate that this cannot be factored again, I'm going to set each of my factors equal to 0 and solve. This factor is going to result in negative 6. My second factor is going to result in positive 6 when I add that over. So either by factoring or using the square root property, both ways will find us the real solutions. Now, when I look at the next example, x squared plus 121, you'll remember that the plus of two squares is not factorable. Now, for this reason, I'm going to apply the square root property. So what I'm going to do is I'm going to take that 121 to the other side. And now you're going to see why it's not factorable. So if I apply the square root property to both sides, the square root property says that x is going to give me two choices, positive or negative. But when I square root negative 121, I have to pull that negative 1 out. And remember that that square root of negative 1 is an I, and the square root of 121 is an 11. So my solution is going to be positive and a negative 11i, which is precisely why it's not factorable, because my solutions are two imaginary numbers. That means when I graph this parabola, that means it's never crossing the x-axis. It is way above it, and the graph of the function will not find the solutions. That's why our solutions are imaginary. It doesn't cross the x-axis. Okay, so let's look at some other factoring scenarios. So this next one, again, this one has a quadratic term and it has a linear term, so I'm not going to isolate. I can't isolate, that won't help me. But I am going to look for a GCF. So if I look at both terms, I see that both terms are divisible by 5 and both terms are divisible by x. So that makes my GCF be 5x, and I'm going to be able to pull out a 5x. When I pull out a 5x, that's going to give me 3x minus 1. All right, now I reevaluate to make sure that nothing can be factored again. When I see that it can't, I apply that zero product property. And I make 5x be 0 and 3x minus 1 be 0. When I divide both sides by 5, I get 0. When I add 1, I get positive 1, and divide by 3, I get 1/3. So I have two solutions to this equation, 0 and 1/3. Now you could see that if I were to graph this one would have been a hard one for me to find the solutions to, because one is landing on 0. That one wouldn't have been bad, but the other one was landing on 1/3. So you could see that this graph is really skinny, and it's really skinny because our A is being multiplied by 15. Okay, let's look at our last two examples. So this last example, again, I have a quadratic term and a linear term, so no isolation is available. So I'm going to look for my GCF. And in this problem, my GCF is just 1, so I have nothing to pull out. So I'm going to go back to normal factoring procedures and factor my x squared. And now I'm looking for factors of 12. So factors of 12 that have to add to be -7. So that would give me a -4 and a -3. So I'm going to pop those in there. And as always, I like to do a good check before I decide those are my factors. So I'm going to FOIL real quick. Firsts give me x squared. Outsides give me -3x. Insides give me -4x, which is indeed a -7x. And lasts give me a +12. So this indeed does factor, and these are the correct factors. So now, once I have it factored completely, I'm going to utilize the zero product property and set equal to 0, and I'm going to have two solutions, and they are +3 and +4. So this would have been an easy one to graph because those two positions would have fell right on that x-axis very nicely. All right, our last example today is 2x squared plus 7x minus 15. And I like to look again. I have a quadratic and a linear, so I can't isolate. I'm going to look for a GCF of all three terms. And of all three terms, my GCF is only 1. Now, because I have an A in this problem, I didn't have an A in the last one, or my A was 1 in the last problem. Because my A is greater than 1, then I'm going to utilize that slip and slide method. Now, this is definitely up to you. You don't have to use this method. But the slip and slide method says, let's take 2 over to -15. And that's going to make this be x squared plus 7x minus 30. Now, that's not a real equation, but that's the one we're going to factor with right now. So x squared, nice and simply, factors into x and x. But 30, I have to find factors that multiply to 30, but subtract, because this is negative, to 7. So I can think of 10 and 7, where 10 is my positive and 7 is my negative to give me, I'm sorry, not 7, 3. 10 and -3 will give me 7. So I'm going to add 10, I'm going to subtract 7, and I'm going to check. My outsides give me -7x, my insides give me 10x. Now remember, my lasts are not going to give me, again, I keep putting a 7 there. That should be a 3. And that should be -3x to give me 7x. I'm even checking incorrectly. All right, sorry about that. So once we get down to here, I reevaluate, but remember that that's not a 30, that's a 15, so we have to slide our values back in there. So let me get rid of this. So since I multiplied 2 by 15 to start, I'm going to divide both of these terms by 2. That's going to make my first factor be x plus 5. And that's going to make my second factor be 2x minus 3. Now if I do a good check, I should be back to the beginning. X times 2x is 2x squared. My outsides give me negative 3x. My insides give me 10x, which add to be 7x. And my lasts give me negative 15. All right, at this point, I'm ready to go ahead and use my zero product property on both terms. And that's going to give me an x is negative 5 and x is 3/2. So let me put those in least to greatest order. And those are my solutions. All right, look for the practice problems on Google Classroom and have a great day.